This week, Bill shows how not to wire AC circuits.
This video is about wiring 120 volt AC, or rather, how not to. Seeing mistakes others have made in wiring can help you to avoid mistakes in your own wiring. Just to prove that anyone can make mistakes, every one of the examples you see in this video are of operating wiring on commercial buildings that are maintained by professionals. And yet, they left it this way. AC, or alternating current, wiring can be very straightforward in how to do it. But to do it safely requires some thought and planning. To help with this, the NEC, or National Electrical Code, was developed. This very thick book is what electricians and engineers use to design and construct electrical systems. Its basic principle is to protect life and property from uncontrolled electrical energy. What you're seeing here doesn't comply with that standard, not even close. And these are electrocution hazards based on OSHA regulations. Some of the work was originally correct, but hasn't aged well. Others were just shortcuts that someone took to get the job done. Or it was a quick fix that they were supposed to come back later and complete, but never did. Let's start with conduit. Conduit is the tube that protects wires from the environment and people from the wires. Conduit can be rigid or flexible. For outside applications, the conduit is supposed to be water resistant, if not waterproof. This is to keep water away from the electricity that could conduct it to people or simply pop the circuit breaker. And really, that would be the best case if it just popped the circuit breaker. If the conduit is broken, it can fill up with water from rain or from people washing down the equipment. And even if it never rains, the wires are exposed to the sun and the insulation breaks down. This will flake off, leaving bare wires that will eventually short out on things. This will cause the breaker to pop, and as a worst case, injure or kill anyone that touches it. Or it could start a fire. No, tape is not a solution to broken conduit. It just falls off after a short time. Sometimes the breaker will pop, and the people in the building will just reset the breaker. Then it pops again, and they reset it again. And this cycle continues until the wire will literally burn up and the equipment stops working. When properly installed, conduit is always attached to something at both ends and is anchored to prevent things from coming apart. It can be connected to other conduit or a junction box. A junction box is where the wires can be connected or a switch can be installed. As with conduit, the junction boxes are supposed to be water resistant and need to protect the wires from the environment and people from the wires. So seeing wires hanging out of the box is not a good thing. Conduit can also be attached directly to some equipment, like motors. These will have a built-in junction box and ways to attach the conduit, and also ways to close off the wires and connectors. While the NEC is important, many don't have the inclination to refer to it or let alone follow it. But the basics of it are this. To protect life and property, electricity has to be insulated from contact with things that could conduct the electricity to where it could hurt someone or do damage. What you saw here were actual live circuits, operating equipment that is critical to the safety of people. These examples really could fail at any time. And this is because of the mistakes that were made. So now you know some of what not to do when working with electricity.
Thanks for watching our video. If you like what you see, press the like button below and subscribe. And also check out our other videos. Like my husband says, common sense is like deodorant. Those who need it most don't use it.